Okay, so the next question we have here is a grams to molecules conversion. And the question is, how many molecules are there in 35.2 grams of calcium nitrate? And in order to solve for this problem, what we're going to need to do is, again, we're going to set up our little table here. Okay, and we're going to put what we know in the top left-hand corner, and we know that we have 35.2 grams of calcium nitrate, NO3 2. Okay, what are we solving for in this case? We're solving for molecules, not moles, but molecules, which is the count of individual CaNO3 in our sample size. So we over here we have molecules, not moles, but molecules of the CaNO3 2. Okay. Now, in order to go from grams to molecules, okay, there is no conversion factor that gets us directly from grams to molecules. So what we're going to have to do is actually break this down and use two conversion factors, and this will show you the advantage to using dimensional analysis to solve these problems. Because although we can't go directly from grams to molecules, what we do know is we can go from grams to moles, and then we know a mole is 6.02 times 10 to the 23rd molecules. So the first thing we need to do is we need to again show just unit-wise how we're going to get from point A to point B. And so the first thing we'll put here is we want it to go to moles, so we'll put 1 mole here, or the label mole there. We want to get rid of the label in grams, so we'll put grams underneath here. And then the next step will be we want to go from moles, again, whatever's up in the top left, you're going to bring down to the bottom right, so it's going to be moles here, and this is going to be our molecules. So we have moles down at the bottom, we have molecules up top. And so this is a convergence factor we can write in right now, because this is one that that if you don't know yet, you should really get to know very soon. And it's the idea that 1 mole, remember mole is just a count, is 6.02 times 10 to the 23rd molecules. Okay, so now over here we know that we want 1 mole, and then it's a matter of coming up what is the molar mass of our formula that is CaNO3 So we want to know what is the molar mass of that. So we have to do a little work down below here. And so if we look up calcium on the periodic table, calcium has a mass of 40.08. Okay, and there's 1 of those. We know that nitrogen has a mass of 14.01, and if we look back up here in our formula, there is 1 nitrogen per nitrate, but we have 2 nitrates, so that means we have 2 nitrogens. And oxygen has a mass of 15.99, and notice that we have 3 oxygens per nitrate. If we have 2 nitrates, that means we have a total of 6 oxygen. So we're going to say that 40, we're going to just round this off here. So this is 40. This is going to be 14 times 2. This is going to be 28. And this is going to be 16 times 6, which is going to give us a value of 96. Okay, and now what we're going to do is we'll total this up. So this is going to be 164, and then we're going to come back up here, and we're going to say that 1 mole of CaNO3 is 164 grams. So now what we're going to do is we're going to do our math here, and how I would go about doing this is where you have multiple things, couple different ways. Really, it doesn't matter. You could actually, if you wanted to, take this number here, your 35 here, and then multiply it by this, and then divide by this. Obviously the ones don't really matter to us. Or we can say this 35.2 divided by our 164 and then multiplied by our 6.02 times 10 to the 23rd. And that's how I would probably go about doing that. Make sure that you're following the proper units. So we have 35. Okay, and so the answer that I am getting is 1.29 times 10 to the 23rd molecules of CaNO3. So that's how we go from grams to molecules. Okay, so the last type of problem I believe that you will see is like a molecules to grams conversion. And so the question is, how many grams are there in 1.8 times 10 to the 25th molecules of LiOH, or lithium hydroxide? So what we're going to do is again set up our little dimensional analysis. What we're starting with goes in the upper left hand corner, and that's going to be 1.8 times 10 to the 25th molecules of LiOH. And over here we're going to solve for grams of lithium hydroxide. Okay, sorry about that. And so again, can we go directly from molecules to grams? No, we can't. In order to go from molecules to grams, we have to first go through moles. And so what we're doing basically to solve for this problem is we're doing exactly what we did in the last problem. If we go back here for a second and look at the last problem, we're going to take these conversion factors, okay, the molecules to moles conversion factor, and then the grams to moles conversion factor, and we're just inverting those. Obviously the molar mass is going to be different for this because we're dealing with a different compound, but we're just going to be inverting those factors. So again, what we want to get rid of, we're going to put on the bottom. So we know we want to get rid of the label molecules. We know we're going to want to have the label moles. Okay, and if you're not really sure what you have here or what this is going to be, you can kind of think, well, I have grams over here. I know that I want my label in grams, and so what do I know? I know there's a relationship between grams and moles, and that's our molar mass. So what we're going to have here is we're going to say that 1 mole is equal to 6.02 times 10 to the 23rd molecules. Alright, now we have to come up with our molar mass. Again, we have 1 mole is how many grams? We have LiOH. So LiOH is over here. And that means we have lithium has a molar mass of 6.94, oxygen molar mass of 15.99, and hydrogen with a molar mass of 1.01. There's one of each of these. Again, when you're within a tenth of the total, within a tenth of a whole number, it's within reason to round. So we can say that the lithium is going to be 7. We can say that the oxygen is 16. And we can say that the hydrogen is 1, and that's going to give us a total of 24 grams. So it's going to be 24 grams per mole. Okay, now the next step is again doing the math here. So we have 1.8 times 10 to the 25th, 6.02 times 10 to the 23rd. Just a quick tip with exponents. When you're multiplying exponents or dividing by exponents, multiplication means that you add the exponents, and division means you could subtract the exponents. So really, in this case, we can think of this as being 1.8, divided by 6.02, and then we can actually do the exponents separately. And really the exponents, because we have 10 to the 25th over 10 10 to the 23rd, what we're really saying here is it's 25 minus 23. So our power of 10, it's going to be again 25 minus 23. Our power of 10 for this particular problem is going to be 10 to the second. And if we do 1.8 divided by 6.02, we're going to come up with a number. We can do this we can just do this in our head. 18 divided by 6 is going to give us an answer of 3, but because it's that would be moving the decimal place in this case. So what we would actually have is 1.8 divided by 6. Our answer is going to be 0.3. 0.3 times 10 to the second can be rewritten if we move the decimal place one spot to the right. We're going to actually get 30 as our answer, or 3 times 10 to the first, which would be 30. So that gives us an answer of 30, and that's 30 moles, because what we've just completed is we've completed the math part for this part of the problem right here, this section here. So then we do 30 moles times 24, and we're going to get an answer of 720 grams of LiOH. Now if you do this with your calculator and you do the math with your calculator, your answer might be slightly different because it doesn't come out to be exactly 30. That's again an estimation based on these numbers here. But that's how you do these problems, and they're really not that difficult. Again, the more you do them, the easier they are. The biggest part is making sure that you're setting things up. The double check on this to make sure that you have everything set up properly is always to just kind of go back and cancel your labels. So we know that here I started off with the label molecules. Molecules over molecules, this cancels this, so that drops the molecule label. Mole divided by mole, those labels cancel, and then this label just comes over here. Okay, so that's how we do that, and hopefully with this piece of information you'll find the homework problems to be pretty easy. Again, take the time though to set this up as I have this here, and I think you'll find it much easier. It'll also be helpful having it set up like I have it set up. It's much easier for me to kind of pick out where you go wrong if your answer doesn't match what we have in class. Anyway, I hope you're enjoying your weekend, and we'll see you guys next week.